Hello friends. In our last video we have discussed about cables. We have discussed about single mode fiber, multi-mode fiber, coaxial cable and twisted pair cable. But today we have to discuss about the cable issues, like we have to identify the collisions, error, duplex, speed mismatch. These are some issues when we transfer data from one interface to another interface. Then there are some cable issues, so we have to discuss about it. Now you are seeing there is a switch, 3560G PoE switch is there. For example, you are going to connect your PCs with this switch. And for example, this is your APC, BPC, C and DPC. Now A want to send data to BPC. Then what can be the issues will be there? First of all, there will be the issue of collision. Now what is collision? Actually collision is a mechanism. Okay, it is a mechanism which is used to control the access by given the bandwidth. Like somebody, some service provider accesses, provides the bandwidth, and collision is a mechanism which is used to access the bandwidth as well as access. So this is the first issues in our network. And sometime when we used to send the data from switch, as we know, switch works on data link layer. Switches are the device which works on data link layer, and data link layer is the layer which is used for error detection also. Sometime when we discuss about OSI model, then we need to know about error detection is placed at data link layer and error correction is at transport layer. So for detecting the error, switch use the concept of cyclic redundancy check and frame check sequence. Okay, in this frames, when the data comes from network layer to our data link layer, then there is one header and trailer attached to data link layer, in which when one PC want to send data, I will clear it. When A PC wants to send data to B PC, then with the network header like packet, it sends header of data link layer, trailer of data link layer. After that, when it sends the data A to B, it sends one CRC value. CRC value, for example, it is a number. For example, A sends the CRC value 3030, and when it receives on B, if the CRC value remains 3030, then there is no error. But if the value is changed here, for example 2030, I'm just taking an example. If number is not matched, then there is a error. The another issues in our cable interfaces, duplex and speed mismatch. Okay, first of all we need to discuss about duplex. Duplex means you can transfer your data in both the direction. Yes, we have discussed before that duplex is of two types, half duplex and full duplex. Half duplex and full duplex difference is, in half duplex you can send your data at one time to receiver, and receiver can receive at single time. When receiver becomes sender, then sender becomes receiver. Like we cannot data simultaneously at one time, but in full duplex we can send data to one interface to another interface at the same time. And sometime in the cable duplex will mismatch. Like for example, I'm taking a router is connected to switch, and this is fast Ethernet port. Okay, and this is switch, this router is connected with another router with fast Ethernet port. For example, here I am using half duplex, here I am using full duplex. So there will be some errors also. So speed may be mismatch. If you want to see practically, then I will show you. I have to use here Cisco packet tracer. I will raise it. For example, this is connected with this. Okay. I will let you know about this software Cisco packet tracer as well as GNS3. I'm just letting you know about show run command. In show run command, when you will check, At interface fast Ethernet 0 by 0, you will check duplex is auto, speed is auto. Okay, I'm just giving one IP address to this. We will discuss about IP address later in the video. So here I'm just using, for example, I just want to show you about it. So no worry about IP address. Okay, so when you go for FA0 by 0 link, then you can check speed. For example, I'm giving speed this to 10 Mbps, then it will check the speed with 10 Mbps operations. If I will give speed 100, then it will give 100 Mbps maximum operation. But this is a switch. Okay. If any router connected to its interface, for example, I will delete the switch and any other router. This one. And here F0 by 0. Okay, I will just do it on it because this is a simulator. I don't need IP address here. For example, on this interface I am using speed 100 and on this interface I am using speed 10. So there may be some errors here. So, and also here duplex, if at one side duplex is full and another side duplex is half, then there must be a problem. There will be a problem here. Okay, so these are the cable issues that we have discussed today. Thank you. Hello friends, today we will going to discuss about TCP and UDP. So in our last video we have discussed about cables, 2-tier architecture, 3-tier architecture, but the important things are protocols. As we know that protocols are the set of rules for communication. Protocols. So we know that these are the set of rules for communication, like we want to send our data from one interface to another interface or one location to another interface. So we need protocols. So we have so many protocols, like in OSI model we have layers: application, presentation, session, transport layer, network, data link and physical layer. But nowadays we are not using OSI. OSI is just reference model. We are using TCP IP model. So according to TCP IP model, these application, presentation and session layer converted into application, after that transport, after that internet layer, and the last two layers are divided into network access. So the one thing is common in both the models, OSI and TCP IP, is transport layer remains same. As we know that on application layer we have so many protocols: HTTP, FTP, DNS, DHCP. But how these protocols are divided? Like, so we have to know about it, how these are divided. So these all protocols are divided into two parts: TCP and UDP. So what is TCP? TCP is transmission control protocol and UDP is user datagram protocol. Okay. Now, what is the difference between TCP and UDP? Actually, TCP is our connection oriented protocol and UDP is our connection less protocol. Now we need to verify the difference between connection oriented and connection less. Okay, I will let you explain. Connection oriented is, for example, I want to send data to any person, and after sending data, for example, this is my location, okay, and this is another person location. I want to send data to PC A to PC B, and in TCP connection, first it will verify the path, like path is clear or not. After that it will get acknowledgement from the destination, like we can talk or we cannot talk. And after that I will send the data. So if we easily understand this, in connection oriented we will get the acknowledgement from the destination. In TCP the connection is reliable, like we can accept updates easily, but TCP connection is slower than UDP, because first it will check the path, after that it will check the acknowledgement, and after that it will send the data. Like in TCP we have three-way handshake process. Three-way handshake process. On the another side, I will give you one example again. For example, I am working in a company, and tomorrow I need a leave, and I need to get permission from my managing director. Okay, so first of all, I just want to say, I will not say directly to managing director, sir, I need a leave. First of all, I will go to my director, sir. Okay, I will go to my director, sir, and I will say, sir, I need to talk about something. Okay, and then if my managing director is free, then he will say yes, otherwise he will say no. Okay, so if my managing director will say yes, then it means one message sent by me, second message sent by my boss, and third time I will send, sir, I need leave. Okay, I need leave, like I have to go to marriage of my cousin, like something. Okay, so this is called three-way handshake. But in UDP there will be no three-way handshake. Okay, I will just clear it again. So it is connection oriented, it is your connectionless, and TCP use port number 6 and UDP use port number 17. UDP is faster than TCP because there is no acknowledgement in this. It will send data. If it will reach, it's okay, otherwise it is error. And it is unreliable, but it is fast. Now what are the example of TCP? TCP examples are HTTP and FTP and SMTP. HTTP is hypertext transfer protocol. For example, you want to like open your website, okay, like www.facebook.com. So with the help of HTTP, it will send the data to server. It will received by port number 80, and after that it will get reply back, and then it will open. Similarly, in FTP 21 port is used and SMTP 25 port is used. So these are connection oriented protocol. But is the example of UDP, DNS, DHCP, TFTP. It use 53 number port, 67, 68 port, 69 port. DNS is used for IP to name. DHCP is used to resolve. DHCP is used for providing IP address automatically. And TFTP works same as like FTP, transfer the data from one interface to another interface. It is used in internet connection. So TCP and UDP has important role in our networking. Thank you so much. Hello friends. Today we are going to discuss about IP addressing. As we know that we have started with our work with network fundamental, and we have done with router, switch, topologies, architectures, so many things. So today's topic is about practical. But before starting the practical, we have to know about the simulator that we are going to use for practice. So the simulator name is Cisco Packet Tracer. As you are seeing that on screen, this software name is Cisco Packet Tracer. This is the software which is provided by Cisco, and it is totally open source software. It is free of cost. You can download it from Cisco's website. There are so many packet tracer websites, and it is official software of Cisco. In the Cisco software, you can make design of your network. You can give IP addressing to network. After that, you have to go with routing technique, switching technique, security technique. So many things are there in this. So okay, let me start with the introduction with Cisco Packet Tracer practically. Okay, so in Cisco Packet Tracer, you will need to know that we have so many series of network devices here. Here you can see there are routers. Different catalyst based information routers are there. 1941, 2901, 2911, After that 89C is CGR routers also, ISR routers are also. And in the switch section, here you are seeing switch. We have 2960 layer 2 switch, some generic switch which are empty. You can add ports here. After that, this is multi-layer switch. This is also multi-layer switch. This multi-layer switch has fast Ethernet port, and this multi-layer switch has Giga Ethernet port. Another, we have hubs. Wireless devices are also there. Cell towers are also there. So we have so many devices are there. After that, if you want to work on cloud, then you can use cloud purpose. In configuration, we have DSL cable, frame relay, so many things. If you want to go for PCs, we have PCs, laptops, servers. This is printer, IP phones, VoIP phone. So this software is a like combo software in which you can go for every network device and you can make their simulation, because it is not able to get original router. These are so they are so costly routers, like it is not easy to purchase each and every router. So Cisco provides a software like Cisco Packet Tracer, so network students can practice their topologies on this. And also there are some features of Cisco Packet Tracer, like you want to write something, then sticky notes are there. You want to make any diagram of their topology, then this is also used. After that, you can make changes with the diagram with this option. This is simple PDU. When we will configure our IP addresses on PCs and routers, then we can use this for pinging purpose. Like if in simulation purpose, you can ping this. After that, we have another options like for example, I am taking one router here. Any router you can take. This is basic router 1841. So you can check here. This is the actual diagram of the router. You can on and off the router. After that, you can add any port, like for example, you want to add switch ports are there, then you can add switch port. Okay, if you want to connect router to router, then you can add serial port here. Okay, so in CLI portion, we have to discuss about the coding. So coding part we'll do later. After that, you can see these are the font of the coding part. So in options, preference, you can choose the font level according to you. If you are choosing 16, then the font size are great. If you are choosing different like 8, 9, 10, like it is according to your need, you want to change the font size. After that, you can check in preference also. If you want to see the animation, you can use show animation. You can go for play sound also there. Show device model name, like device model name is 1841, you want to hide or you want to see. Show device label, device name label, like router 5, router 6. If you want to disable auto cable here, then you can disable this. So there are so many things basic. When we do practice, then day by day you will learn about it. Okay, so in cable part we have discussed about straight cable, cross cable. So if we are going to make topology here, okay, so first of all, how to delete this? Then we have a cross button here. So cross button is used to delete the component. For example, you want to make design like this, okay, router to router. So I told you that in router you can switch off the router, then you can add HWIC2T port here on, and on another router you can also add HWIC2T port here. For example, you have not add port in this router. So when you will click on cable connection, then you will find console cable, straight cable, cross cable. After that, fiber cable is also here, serial cable. So router to router HWCIT2T port means serial cable can be connected. But on this router, serial port is not there, so you can connect router to router with cross cable also. This one. And if you want to connect router with switch, Okay, then your straight cable will be used. And if you want to connect PCs with switch, then again straight cable will use. Fast Ethernet, fast Ethernet. Okay, so this is the designing part. So first we want to start with practical of IP address. Then before IP address you need to make about design. Okay, so in the next video we will discuss about IP addressing on my PCs and also IP address with subnetting part. Thank you. Hello friends, today we are going to discuss about again Cisco packet tracer, because in last lecture we have discussed about only Cisco packet tracer, like what are the options in Cisco packet tracer, how we can write image, how we can use sticky notes, how we can make a design. So in today's part we have to discuss about some basic commands that we have to use in CLI. So first of all, we need to know about the modes of router. Before practical work on Cisco packet tracer, we need to know about the modes of router. So when you are going to start router, so I am using one router here. For example, I am using 1841. I will click on CLI. So in CLI, first time it will boot, and after that it will ask from you, would you like to enter initial configuration dialog? So you have to put no, because we have to do all the things manually. So I'm going to change the font size like on 14, it may be good. So this is your router. So here you can see the mode router. In this you can see the router look like this. So this mode is known as user mode of router. In Cisco packet tracer we are finding. In original also it is using like this. Okay. Wait. So this is your mode. Now if I put here basic command enable, then you can see the router is changed. The router mode is changed from this type to this type. So this is called privilege mode, and you can call it as enable mode. Like you have to use one command enable here. Okay. After using the enable command here, I have one more basic command here, configure terminal. If I will use this command configure terminal, then routers looks like this. So these are the basic three modes. First mode name is user mode, second is enable mode, and last is global configuration mode. So the basic configuration of router and Cisco packet tracer is same for every practical. For IP addressing, for IPv6 addressing, it is same and it is equal. So we have basically three modes of router. One mode is user mode, and after putting enable command, second mode is privilege mode, and last is global configuration mode. So global configuration mode is used to do for all the configuration of router. So first of all we need to find basic commands of Cisco routers. So I need to have notepad. So in enable mode, which type of commands we can use? So I am going to explain you about basic commands. Okay, so I am just using 5 to 6 commands here. Okay, the first command is show run, and you can call it as show running -config. You can write it like it as. You can use show run or show running configuration. This command is used to see all the running configuration of router, like what is the original configuration on router. If the router is old router and we have some configuration, so we have to find all the configuration with this command. And if anything is saved on this, then the command is show startup config to see the saved configuration. Okay, one more command, write, is used to save the data. Show startup config is used to see the saved configuration, but for saving we have to use write command. I am using these commands in enable mode only. Show IP route. Show IP route is for to see the routing table. Like after that we are going to configure routing, so I have to use this command. Show IP interface brief. It is used to see interface information, like which interface is assigned with that IP address. And after that, if you want to delete all the configuration, erase startup config is there. And after that, you have to use command reload. And there are so many other commands are there. Show history is there if you want to see history. Show clock is there to see the time. Set clock set is there to set the command. So one by one, when we are going to do some practicals, I will let you know and explain each and every command of router. So after this, just try to move on to Cisco packet tracer. So this is my router. I just want to let you know about basic mode commands. So I'm using exit here. This is enable mode, like show running config. This is used for all the running configuration of router, like this. All the running configuration, and now no person has saved any data on this. So if you are going to use show startup config, then there is no startup config. But if you will choose write command here, then in show startup config you will get the command of show running config. The same thing that you have seen in running configuration, that is going to saved into NVRAM to RAM. So it is in startup config. And if you want to see the history of command, then show history is there, like how many commands I have used before. Show IP interface brief. It is used for brief information of interface, like interface is down, protocol is down, IP addresses are unassigned. Show IP route is for routing table, but this command we will show you when we have configurations of the router. So in next video we will discuss about the design of IP addressing. Thank you. Hello friends. Our today's topic is about logical address of networking, which name as IP address. So today we are going to discuss about what is IP address. But before IP address, we need to know one more topic here, which name is LAN and WAN. Like what is local area network and what is wide area network. Okay, so I'm going to start with the local area network first, because in both local area network and wide area network we are going to use about IP address. Okay, LAN means if devices are connected with each other with same network IDs. Like for example, we have two devices and they are connected with one cable, then they have same network ID, it means they are LAN. Wide area network means if devices are connected with different network ID and another device named router is being used here. So the difference between LAN and WAN is LAN is used for small area purpose and wide area network is used for like worldwide connectivity. In LAN, devices are with same network ID and switch or hub are using in this LAN device. But in wide area network, router is used with different network ID. So first of all, we need to know about what is a network ID, because with the help of network ID, we can make LAN and WAN. So network ID is a part of IP address. It is a part of IP address. So our today's topic is IP address. Okay. So IP address is Internet Protocol address. We have two types of IP addresses are there, IPv4 and IPv6. But today I am going to discuss about IPv4. After topics, we will discuss about IPv6. IP address is your unique address, as well as it is in the form of decimal, because computer supports decimal language. But on the very start, we have discussed about computer, that computer is an electronics device which works on 0 and 1. 0 and 1 means binary. So all the addresses are at very first space, these are in binary format. So same as IP address is 32-bit address, and we have divided it into decimal address. So the company which standardized the IP address is named as INA, Internet Assigned Number Authority, and they have divided into 4 octet, like 8.8.8. part. And some part in this IP address is network ID and some part is host ID. Okay, so if we know about binary to decimal, let me start with one basic introduction about binary to decimal. Like, for example, we have 32-bit IP address, then we can understand all bit can be 0, all bit can be 1, and some bit can be 0 and some can be 1. So 0 means 1, 2, 3, 4, 5, 6, 7, 8 dot. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 and 1, 2, 3, 4, 5, 6, 7, 8. 1, 1 means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And after that 24, 32. So some 0, some 1 means 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, anything. So if we want to get lowest IP address, then we are going for binary to decimal conversion of this bit. And if we need highest IP address, then we need to go for this address for binary to decimal. This one, binary to decimal. So if we go for binary to decimal of 0 address, then what would you need to know about, learn about binary to decimal? Multiply. So each and every bit multiply with 2 raised to power 0, 1, 2, 3, 4, 5, 6, 7. Like these are the prerequisites of CCNA. You need to know about binary to decimal concept at a very first place. So 0 multiply 2 raised to power 0, 0, plus 0 multiply 2 raised to power 1, 0. So everything should be 0 here. So if 8 zeros of binary becomes 1 0 in decimal, so 32 0 means our first IP address should be 0 0 0 0, like this. This is my very first IP address in decimal. Okay, understand the concept. Now I am going to binary to decimal of 1111. So you can check here 1, 2, 3, 4, 5, 6, 7, 8. Multiply 2 raised to power 0, 1, 2, 3, 4, 5, 6 and 7. So 2 raised to power 0 is 1, 2 raised to power 1 is 2, 2 raised to power 2 is 4. This is 8, 16, 32, 64 and 128. And if we multiply 1 with 128, then same number will be there. 1 multiply 64, same number will be there. So when we add these number, 255 figure will be there. So if 8 bits becomes 255 in decimal, then the highest IP address should be this. 255, 255, 255, 255. So basically 0.0.0.0 is lowest address, 255, 255, 255, 255. This is my highest address. Like my range should be, my IP address range should be 0 to 255 only. But INA company divided, Internet Assigned Number Authority divided this IP address into 5 classes. Classes of IP address: A class, B class, C class, D class, E class. The range of A class is 1 to 126 B class is 128 to 191, 192 to 223, 224 to 239, and 240 to 254. So 0 is missing, 127 is missing, 255 is missing from the range 0 to 255. 0 is reserved for default route that we will discuss in default routing technique. 127 is your loop back address, like you want to ping with yourself only. For example, your PC wants to ping with your own LAN card. So we will ping with one command 127.0.0.1. Okay, 255 is reserved for broadcast. So it is reserved for broadcast. Okay. So now range, I will clear this, and again watching clear range of IP address: A class, B class, C, D and E. Like if any IP start from 1 to 126, it is from A class, 128 to 191 V class, 223 C class, 224 to 239 and 240 to 254. Okay. First C class is used as an IP address in our networking, like 1 to 223. D class is reserved for multicasting. It is not used for IP addressing purpose in our PC. E class is reserved for scientific research and recovery. So it is also used by the INA team. So we don't need to discuss these IP address this time. Okay, so we know that now IP address range, like our starting range was 0000 and highest range was this, but in actual that the usable range of IP address is 10002 128.255.255.255. This is A class. 129.0.0.0 191, sorry, 128 here. Here I have to use 126. 128 to 199, 255, 255, 255. This is B class. And 192.0.0.0 to 223. These are the actual usable range in our PC. So if we are going to use D class, E class or loopback address as an IP address, it will be not configured. It will gives you error that 127 is used for loopback, 0 is not a valid entry, like this. So this is the valid range. So this is non-IP address. So this is IP address. In next video we are going to discuss about subnet mask and fixed length subnet mask, because IP address is only a logical address of PC, but we have to make network ID and host ID first, and we have to create LAN and WAN. So we need to discuss about subnet mask in next video. Thank you. Hello friends. So in our last part of our video, we have discussed about LAN and WAN and IP address. Okay, so in last part, what we have discussed about, what is LAN, same network ID, what is WAN, different network ID, and we have discussed about IP address in our last lecture. So after the conclusion, we discussed about that A class is 1 to 126, B class is 128 to 191, C class is 192 to 223. Okay, so what we have discussed that A class IP addresses are 10002, 126, 255, 255, 255. But actual IP address 10012, 126, 255, 255, 254. Like these are the valid IP addresses. Same as for B class and same as for C class. But our topic is pending that how we can represent it like a LAN, how to make LAN and how to make WAN. So with these range of IP address, we need to know about one basic concept, that IP address are not only a single part for communication. We need one more part of IP address with the communication, that named is subnet mask. Subnet mask. So if you will try to give IP address of A class to any PC, like you are going to give IP address to your LAN card, then you will check, then when you give A class IP address, then automatically this value will placed in subnet mask option. In B class, 255.255.0.0 will be there. In C class, 255.255.255.0, this will be there. Like for example, here we have one PC. Okay, for example, this is Rajiv's PC. Okay, Rajiv's PC with connected with any other PC like XYZ. So Rajiv has given 10.0.0.1 IP. So automatically Rajiv will get 255.0.0.0 subnet mask. If Rajiv will give 172.16.0.1 IP, so it is in the range of B class. So Rajiv will get this subnet mask. And after that, if anybody use 200.0.0.1 IP, we know that it is the range of C class. So we will get this subnet mask. So this subnet mask is the like important part of our IP address. How? Because it has some key roles. What are the key roles? Because if we have subnet mask, then we easily divide from IP address that which part is my network ID and which part is my host ID. So with the help of subnet mask, we can divide this. Okay, let me clear this once, and I will write subnet mask again. A class subnet mask is 255.0.0.0. Okay, so first we have to see A class. So this is a range of IP address. So what is the meaning of 255 in binary? 1, 2, 3, 4, 5, 6, 7, 8. 0 meaning 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Done? So this is the meaning of subnet mask, that there are 8 ones and 24 zeros are in there in A class. Okay, so it means that on bits are in A class are 8 and off bits are 24. Similarly, if we give B class IP address 255.255.0.0, then 8 ones, 16 ones are in B class and 16 zeros are in B class. So this is the portion of A class. In B class, on bit are 16, off are 16, like both are same. In C class of subnet mask, this one 24 ones and 8 part of 0. So in C class, on bit are 24, off bit are 8. Now the important concept in this, if in computer language 0 known for off bit and 1 is known for on bit, then in network part, on bit represents network ID. On bit means 1. It represents network ID and off bit represents host ID. Okay, understand the concept. So if we check in A class, 8 bit are of network ID, 24 bit are of host ID. Like host ID means how many hosts can be used in this network. In B class, 16 bit is network, 16 bit is host. In C class, 24 bit are network, 8 bits are off. Okay, let me clear you here. So for example, if we are using subnet mask, like it is used to divide, like if anybody asks you from that why we use subnet mask if we have IP addresses, then subnet mask is used to divide network ID and host ID from IP address. How? Because in A class 8.1 and 24.0, in B class 16.1, 16.0, and in C class 24 1 8 zeros, and 1 means network ID and 0 means host IDs. Okay, what is the meaning of host ID? Let me explain. Host ID means in A class 24 bits are host, means 2 raised to power 24 host we can use, approximately 16 million. It is not the exact value, like it is 1 crore 60 lakhs. Okay, 16 million. 2 raised to power 16. In B class we can use 65536 IP address. In C class we can use only 256 IP address in my class. So network ID and host ID like represents that A class, B class, C class have their exact value of host, like in one class how many hosts I can use. Now come to the main point. We have discussed about in IP address LAN and WAN. In LAN, the portion of LAN same network ID, and WAN means different network ID plus router. Don't forget this thing. Like if you have one PC connected to another PC, okay, for example this PC's IP address is 10.0.0.1, so it is A class, so it is my network part, because subnet mask is going to represent that 8 bit of IP address are network ID. If second PC have same network ID like 10 and host can be any, like both are from A class, if network ID is same, then this is called LAN. Even if you are using any B class IP 160.1.1.1, but subnet mask is this, so this part should be network ID. If you want to make this LAN, then your both 16 bit you have to be same and another bit you can to be different. This is called LAN. Same as for 200.2.2.2, so 255.255.255.0, this part is your network ID. Then on another side 200.2.2 should be same and host ID should be different. This is called LAN, local area network. And in WAN we have to say different network ID plus router is being used. So for example, we have one switch and we have 3 IP address are here, like 20.0.0.1, 20.0.0.2, 20.0.0.3. So we have subnet mask 255.0.0.0. So if my 20, 20 and 20 is same, it means this is my LAN. Like you can say LAN 1. And if you want to extend this, you can use switch also, cross cable, like 20.0.0.4. Even we have multiple switches, but my network ID should be same, it is again LAN. But if we have another switch that has like for example class is same, but IP address is 50.0.0.1, 50.0.0.2, 50.0.0.3. Now class is same, 50.50.50, so this is called LAN 2. But 50 is different from 20. So if we connect this, it will not connect because network ID is different. So when we connect this switch with one router, and router is connected to this. Now router is a device which works on different network ID. For example, here router is using 20.0.0.10 IP. Here router is using 50.0.0.10 IP. So on the both port of router having different network ID, and router is going to connect with 20 to 50. So different network ID plus router concept becomes WAN. So this is the exact definition of WAN. Thank you so much. Hello friends, our today's topic is FLSM, because in our last lecture we have discussed about what is IP address, what is LAN and WAN, what is subnet mask. That IP address is my unique identity. Subnet mask is used to divide LAN and WAN, sorry, network ID and host ID. And with the network ID and host ID concept, you can make LAN and WAN. Now, what is fixed length subnet mask? You need to know about this. The short form of fixed length subnet mask is FLSM. So in FLSM, we need to verify like how many networks are in one IP address, how many hosts are in one IP address. So if we take A class very first, like the subnet mask is 255.0.0.0. So we know that network part is 8 and host part is 24. 24 means in this we are going to use 16 million approx IP addresses. So in FLSM, what we need to find? We need to find from IP address. So this is subnet mask. I'm taking any 1 to 126 IP address like 20.0.0.0. This is my network. So what we need to find in FLSM? So we need to find from IP address what is my network ID, what is the first valid IP address that I can use in my network, what is my last valid IP address that I can use, and what is broadcast ID. So in FLSM we need to know about this part. Okay, so I'm taking an example. 20.0.0.0/8. 8 means that 8 bit are on. So what is the network ID for this? So 20.0.0.0. The very first IP address is known as network ID. For example, I am writing here 120.20.0.0.100. So the network ID of this part should be 20.0.0.0. The first valid IP. Valid IP means that IP address I am going to assign to my computer. So we know that this is network ID, this is first IP, this is last IP, and this is broadcast ID. We know that with LAN and WAN, if 255 subnet mask 000 is there, then 20 should be same in this part. It should be same, and this part is variable. So first IP address is 001. And what is my broadcast ID? If my IP start from 000, then definitely it should end with 255.255.255. So if after network ID my first valid IP should be there, then before broadcast ID my last IP address should be there. It is the example of A class only. Understand? Like if we have to complete 16 million IP address, then first time it will go to 0 to 255, then 1 should be there. Again 0 to 255, then 2 should be there. Again 0 to 255, then 3. Then 256 times 256 should be there. Then this part will become 255. Then 1 should be there when again this process 0 to 255, 0 to 255. To 256 multiply 256 multiply 256 is equal to 16 million IP. Okay, let me take one example of B class first. For example, I have 160.0.1.1. This is IP address, and 16 is the on bits are there. So network ID, first IP, last IP, and broadcast ID. So we know that the subnet mask is 255.255.0.0 is there, this part. Understand? So 160.0 remains same in network ID, first IP, last IP, broadcast ID, this part. Okay, so network ID is represented with 0 and 0 as I told you in A class. Broadcast ID is represented with 255.255. So it is starting IP address, it is last broadcast IP address. So first valid IP is 0.1, last valid IP is 255.254. Easy. And in C class, for example, this is one or 10 or 100. No worry about it. Class will start with 0 only. 200, 1, 2, 3, 24. So the network ID, first IP, last IP and broadcast ID. But first I have to write FLSM, fixed length subnet mask 0. So 3 times 255, it means 200, 1 and 2. It remains same. Okay. So starting from 0, first IP is 1, last IP is 254 and end IP is 255. So in FLSM we need to find what is my network ID, what is my broadcast ID, what is my first IP and what is my last IP address. Thank you so much. Hello friends, our today's topic is about VLSM, variable length subnet mask, and the main concept name is subnetting, and it is the most important topic of your networking. Like in our last videos we have discussed about LAN and WAN, we have discussed about IPv4, subnet mask, and at last we have discussed about FLSM. In FLSM we know that we need to find our network ID, first and last IP, and after that broadcast ID. But in FLSM there is a problem. What is the problem? Like for example, if I need 300 IP address within one LAN network, then I'm not able to choose C class, because C class subnet mask is 255.0.0.0, sorry, 255.255.0. Okay. So in this, network ID is of 24-bit, but host ID is for 8-bit only. So 2 raised to power 8 means 256 IP address. So I need 300 IP address, so I have to move on into B class. So in B class, 16-bit host means 65536 IP. Now the concept is like, if I'm taking 300 IP address from this range, 65536 IP address, then 65236 IP addresses are not able to use in any other network. Why? Because the WAN rule is this, that you can choose different network ID with the router. So I have to use all the IP address in one class, but I need only 300 IP address, so I have a big problem about it. To solve the wastage of IP address, that's why we use VLSM, variable length subnet mask. So the overall concept name is subnetting. So what is subnetting? Subnetting is the process of divide one large network. For example, this is large network. Divide one large network into small subnetworks. Small subnetworks. Like I have to divide this room into 2 parts. So 2 network will be there, 4 network will be there, 8 network will be there, 16 network will be there. Like I have to divide one exact space into 2 part, 4 part, 8 part, 16 part, 32 part. Okay, let me take an example. So I'm going to start with C class. So I'm taking an example of this 192.168.1.0/24. So this is, I know this is class full network, but I'm going to choose it as a classless network. Okay. So first of all, we need to follow some basic steps in subnetting. So first step is find VLSM. Okay, so 24 means 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And after that all zeros. Like all 0 means 8 zeros. So VLSM is 255.255.255.0 and the value remains this. This is known your magic value. Like we don't need to follow fixed bit. The values remaining is known as magic value. And the third step is block size. The formula of block size is 256 minus 0 magic value. So I have to minus magic value into 256. Fourth and fifth part is number of networks. Like if we are using this network, what are the number of network? So I'm using a number of network is 2 raised to power n. N means on bit. So I don't have to choose from already fixed bit. Like in A class 8 bit are fixed, B class 16 bit are fixed, and C class 24 bit are fixed. So I don't have to choose from this. I have to choose from magic number. So how many bits are on? No one is on. So n value is 0, network is 1. Number of host 2 raised to power h. So h means off bit. So 2 raised to power all bits are off, 256. So within one network I have 256 IP. Yesterday's video, last videos we have discussed that in one network 256 IP. So I have to find network ID, first IP, last IP and broadcast ID. So what is my network ID? 192.168.1.0. First IP is 192.168.1.1. Last IP is 192.168.1.2 and broadcast ID is 254. This is second IP, this is last IP and this is broadcast ID. So this is the steps that we have to follow in subnetting. Okay, so this was the classful network. Let me take an example of slide 25. Okay, I will write the steps on notepad. Okay, wait. So my first step is find VLSM. So I will write it on this. After that, magic value. This one. Okay, so it will help you to make the video good. And after that magic value, we need to find block size. And after that I have to find number of network, and at last I have to find number of host. And after that we need to find one more thing, valid network, valid host. So this is after this. Okay, so I am taking an example of one number. Okay, so let me take 200.0.0.0/ I'm using 25 here, like one bit is on in this. Okay, so one bit is on, this one. Okay, so what is the VLSM here? I'm taking one space here for understanding you. What is VLSM here? 25 means 255, 255, 255. These are the 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Now 25 means one more bit is on. 25, 26, 27, 28, 29, 30, 31, 32. Okay, so when we do binary to decimal, then this value should be 128. So now this is my subnet mask. This is variable length subnet mask. So now magic value is 128. Block size is 256 minus 128 is equal to 128. Number of network 2 raised to power n, one bit is on. So number of network 2. Number of host are 2 raised to power h, 7 zeros are there. So this is the exact value. Like within two network, 128 IPs. So what I have to find? Network ID. first IP, last IP and broadcast ID. So I have two networks. Okay, the network is 200.0.0.0 and the block size is 128. So 200.0.0.128 is my next network. So in this, first IP should be 200.0.0.1, last IP 126 and broadcast ID is 127. So this is 129 is my first IP, last IP is 254 and broadcast IP is 255. Okay, if we need to find now what is valid network and what is host. So you have seen that first network ID and last broadcast ID is not used in host. Okay, so the valid hosts are 2 raised to power h minus 2. Like if 128 are the host, then valid hosts are 126. And valid network is same as 2 raised to power n minus 2. Like if 2 raised to power n 1. So here we have only two networks. So in this, valid networks are 2. So network I have to find like this. Sorry. Valid host I have to find like 128 minus 2. Okay. So if I have 256 IP in one network, then 254 is the valid IP. If 128 IPs are valid, then 126. Like we have to do with minus 2. Okay, let me take an example, another example. Okay, so 25, 26, 27, for example, I am doing for 29. Okay, so what I have to do for 29, like 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 24, 25, 26, 27, 28, 29. This one. So VLSM is 255, 255, 255, 248 because binary to decimal 2 raised to power 7, 6, this one. 248 is the magic value. Block size formula remains same. Number of network 2 raised to power 5. Number of hosts 2 raised to power 3. Now, how I am easily understanding the concept, because I am using these values. 5 ones means 5n. 3 zeros means h is equal to 3. 32 network and 8 host. But exactly I am using 30 network here because 0 network I am not going to use. Okay? And after that 200 last network 200.0.0.248 I am also not going to use. But here I have to work on valid host. So valid hosts are like 6. How? Now 1, 2, 3, 4, 5 up to 32 network I have. First network is 200.0.0.0. Block size is 8. 200.0.0.8, 16, 24, 32 like this. And after that 1 to 6 is the valid IP, first and last. 7 is your broadcast. 9 to 14 and 15 is your broadcast. 17 to 22, 23. 25 to 30, 31. Like you have to follow the same rule that I have used. Okay, so I will write like if I am going to use all the network, then I am showing you the value, exact value of slash. So when I am using slash 24, okay, then I know that this is class full. 25 class slash 26, 27, 28, 29, 30. So I am going to provide cheat sheet. Okay, here is cheat sheet for you. 255 means easy. 255, 255, 0. Now 25 means 1 bit is on 128. 2 bit is on 128 plus 64, 192. Here 128 plus 64 plus 32, 224. So you have to solve these R values because in video I can solve only limited values. Okay, so just solve this. 255, 255, 255, 248. This one I have solved just right now, and 252. So exact what you have to see. Okay, in this I have 256 IPs, but when I solve this 128 IP, 64 IP, 32 IP, 16, 8 and 4. These are the total hosts that we are using. So if anybody asks from you like what are the valid hosts, so just do one thing, -2, -2, -2, -2, -2. So the valid IPs in /30 is 2. So I'm writing with this. So valid IP in this 254, 126, 62, 30, 14, 6 and 2. So with the help of this we can do subnetting. Thank you so much. Hello friends. Our today's topic is about IP addressing configuration. This is the totally practical topic. So today I'm going to let you know about like how to configure router and how to provide IP address with subnetting on our design. Okay, so let me start with the design. So I'm going to use this router 1, 2, 3 router, and I'm going to use 3 switch 2960 is there. These router and switch we have already discussed in our last lecture, like what is router, what is switch. So in end device we can get 1 2 1 2 1 2. Okay, you can choose one more IP if you need. Like it's about you that you are going to choose how many PC in your network. Okay, so I told you about in last Cisco packet tracer video that if you are going to connect PC with switch, then you are going to use with straight cable, fast Ethernet, fast Ethernet, fast Ethernet. So I'm going to use this command. Sorry, this is cable connectivity. After that I have to put command here. So from switch you can choose any fast Ethernet interface, it's up to you. So our LAN network, 3 LAN networks are completed now. Router to switch I am going to choose again fast Ethernet. Okay, but I told you that if you are going to connect with router to router, then you can choose cross cable. Okay, but for example you are not going to choose fast Ethernet cable here, then you can choose off the router. You can choose here HWIC2T port here and on the router. Okay, so with this what you can do, you can add an WAN interface card in your router. After this you are able to connect your router with serial cable. Here is serial cable. So connect serial 000 000 001 000. Okay, so no worry about like 001 is going to connect with 001 only. You can connect it with 000 only. Okay, so now here I need to provide IP address. Okay, first I want to explain. For example, this is my first network. Okay, second network and third network. So in these network we have 1, 2, 3 and 4. Total 4 IP I need. Here I also need only 4 IP address. Okay. So in last subnetting video, in that video we have discussed about like if we need 2 valid IP, then I'm going to choose /30, 6 valid IP /29, 14 valid IP /28. So here I need only 4 IP, so I am able to choose /29 here. Okay, 4 IP. I'm erasing this and I'm writing here /29, because with the help of subnetting we have to configure this. And here we have a network where we need only two IP address, so I can choose /30 here, /30, because we need only two IP address. And now in FLSM we have to use about like A class IP, B class IP, C class IP. But with the help of VLSM you can choose any IP address here. Okay, for example, here you want to use another network, here another or another. For example, here you want to choose, like, I'm just taking an example. Here you want to use A class, then you can choose this. Here you want to use B class, then you can choose /29. Here you can choose C class. Okay, so within WAN link you can choose any IP address, like here 20.0.0./30 and 30.0.0.0/30. So the meaning of these IP addresses, like here I can put IP address 1, 2, 3 and F0/0 is 10.0.0.4. Here I can give 172.16.0.4. Here I can give 192.168.1.4, and the IP address assigned to fast Ethernet port is known as the default gateway for LAN. So let me start with practical right now. Okay, so I hope that you understand the concept. So first of all, I am going to configure my, okay, let me erase this, 10.0.0.1 255.255.255.248, because /29 I'm using and gateway is 10.0.0.4. So I'm just copy the gateway because I have to choose in another network also. 10.0.0.2 and subnet mask I have to change manually. 10.0.0.3 255.255.248 and 10.0.0.4 is the gateway. Okay, so I can write in sticky notes also 10.0.0.4. Here I want to use 172.16.0.4. Here I am using 192.168.1.4. The IP address here is 20.0.0.1 but /30, 20.0.0.2, 30.0.0.1 and 30.0.0.2. Okay, so in this also I have to choose 20.0.0.1, 255, 255, 255, 248, 20.0.0.4. So I am going to copy this subnet mask because I have to type again and again. 20.0.0.2. So paste the subnet mask 20.0.0.4. This is easy. 20.0.0.3. Okay. 20.0.0.4. So here, oh sorry, my mistake. Here I have to choose 172.16.0.1 because I am choosing WAN for 20 IP address. So not an issue. We can change just within 1 minute. Here I am using 2 and 4. Three and 4. Okay, so here I have to choose IP address with 192.248 and 192.168.1.4. So if you are going to start with first time, then sometimes you will face some problems, but it is very easy coding. You don't have to worry about it. Okay, so the last IP address is Done. So my PC's IP addresses are configured. Now I have to configure router, the important part. Okay, so in our last video we have discussed about CLI command. We know that we have to put no here. First command is enable, and after that I am going to choose config terminal command. So now how to provide IP address to router. So we have two ports of router, fast Ethernet and serial. So I am going to give interface fast Ethernet 0x0 IP address 10004. So this is the gateway for LAN 1 and the subnet mask should be 248. Okay, actually I have put tab, so that's why you are seeing three commands. So by default the link of router is down, so you have to use command here no shutdown. When you will use command no shutdown, the link will be up if it is connected to switch. If it is connected to router, again router, then you have to no shut command, put no shut command on another router also. So exit interface serial 0/0/0 IP address 20001, and here I have to use 252 because /30 I am using. No shutdown, exit. Okay, so I told you about one thing, that if you want to see running configuration, then you have to use that command in enable mode. Show run, that you can easily see this IP address is configured with this is configured with this. Okay, I will going to configure second and third router before that I am going to introduce one more command. For example, you are checking show run command in config mode. Okay, show run, then it will provide you error invalid. So the concept is, if you are going to use enable mode command in config mode, then you can put do keyword before that. Like if you are using show run in enable mode, it is right, but if you are going to use show run in configuration mode, then you have to put do keyword before command. This one, like do show history, do show IP interface brief. So this is the basic commands. Now move on to router 2. So on router 2 I have three interface. Okay, I am using short forms, enable and config. Okay, so I have three interface, fast Ethernet, serial and serial 001. So it's up to you that you are going to configure at very first which interface. 172.16.0.4, 255, 255, 255, 248, and then no shutdown. Easy. And after that, exit this interface, go for interface serial 000 IP address. Now this port IP is 20001, so definitely this should be 20002. 255, 255, 255, 252. No shutdown. So this link should be up. That's it. Okay, you want to see the history in between configuration, then you can put command do show history. Like if you want to see this, but our one more interface is left. Interface serial 0/0/1 IP address, this one 30001, no shut. So this one. Okay, if you want to save the configuration, then I told you that you can use command write, but if you are going to use in this configuration mode, then you can put do write. Building configuration, okay. In first router I'm going to change do write. Now this configuration is saved. Okay, now move on to third router. Third router is also same as enable configure terminal interface fast Ethernet 0x0 IP address 192.168, sorry, 195. I wrote 195 instead of 192. 1.4, 255, 255, 255, 248. So again, no shutdown. The link is up, and after that, interface serial 0/0/0, IP address 30.0.0.2, and no shutdown. So if you want to save this, do right. Okay, so this is done with my IP addressing with subnetting. Okay, now you want to check basic command here, like, okay, sometime, one more thing, sometime this error will be there translating domain server, then you have to choose Control-Shift-6. Okay, you have to choose Control-Shift-6 in this, and after using this, name lookup will be aborted. So show IP interface brief. It will show you which interface is assigned with which IP address. Okay, show IP route. So show IP route will provide you the routing information, like 10 and 20 are the direct network of this router. Okay, so this was the configuration of IP addressing. Thank you. Hello friends, our today's topic is about IPv4 private IP addressing. Okay, in last video we have discussed about the practical, like how IPv4 addressing will be configured. Okay, but today's video we have to discuss about like why we need private IP address. Okay, first of all we need to know about the private IP address. As we know that we have classes. So if we have classes like A class 1 to 126, B class 128 to 191, and C class 192 to 223. Okay, so in that the range of IPv4 addresses are same, but these all are known as public IP address, like those are the routable IP address over the internet. So the private address range is from A class is 10.0.0.0 to 10.255 to 55 to 55, and 172.16.0.0 to 172.31 to 55 to 55, and from C class 192.168.0.0.0 to 192.168 to 55 to 55. These are the reserved private IPv4 addresses, and these IP addresses are not routable over the internet. Like it turns out that private IPs also came in handy as a means to save valuable public IP addresses, like public IPv4 space. Okay, in other words, I want to explain that without these private addressing, we would not have any more public IPv4 address to hand out today to a new device. Yes, we have subnetting options, we have NAT options also, but in any cases, private IPv4 addresses go a long way because they can be used by many. And many different peoples, many businesses, many devices are used with this. So you do have to turn them into some sort of public address if you want to use. Okay, so private IP addresses are not able to use, but in many companies, everyone is going to use with private IP address. These are not public; these are private IP addresses, and these IP addresses are not routable. So with the help of private IP address, we are easily have to use and save public IP addresses. Thank you so much. Hello friends, our today's topic is about one of the most trending topic of our networking, which name is IPv6. Okay, in our last video we have discussed about IPv4 address. Okay, and we have configured our IPv4 address on Cisco Packet Tracer, and we have discussed about how to do subnetting and how to do configuration on routers and PCs. So our today's topic is IPv6 Internet Protocol version 6. Internet Protocol version 6. Okay, first of all, why we need IPv6? Actually, in our IPv4 addresses, if we talk about IPv4, then in IPv4 address we have a 32-bit address and 4.3 billion IPv4 addresses are there. And we know that the all over the world population is going to be 8 billion. Okay, within just years or 2 years, it will become 8 billion. And we are using private IP address, we are using subnetting. But at one time IPv4 address are going to not in the use in the market because it is already used. So that's why we need one new IP address. That name is IPv6. So what is the difference between IPv4 and IPv6? In IPv4 it was 32-bit address, it was the decimal address, it was represented by dot, okay, it was represented with 4 octet, it has classes, and we have done with classes subnet mask. And in IPv4 address is what we have learned about classes is done dot 4.3 billion IPv4 address approximate. So in IPv6 it is 128-bit address, it is in the hexadecimal format. Okay, it is represented by colon, it is represented like this 16 colon 16 16 this. So it is a huge and large IP address. It has no concept of classes. Okay, instead of subnet mask, IPv6 is using CIDR value, like we call it prefix length. Like in IPv4 we were using like this 10.0/8/172.16.0/16 192.168.1.0/24. okay, and after that we will convert this value into subnet mask like 255.0.0.0, 255.255.0.0 and 3 times 255.0. But in this IPv6 we can only choose prefix length. Okay, so how to write IPv6 address? Okay, so first of all, for example, this is my IPv6 address. I'm using IPv6 address 00000001 and 1 2 3 4 5 6 7 8. Okay, so 8 hexas are there. So in this I can choose like 0db8 010001. Like instead of 40 I can put single 0. Okay, so if you want to shorten the expression of IPv6 address, you can also use like this 2001 0db8 01:1. Like group of 0 can be represented with double colon. But for example, sometime we got 2001 001 0.001234567 So now we have two group of zeros. Okay, so you can write this IPv6 address like this, or you can write this :1. But you are not allowed to use two double columns like 2001 :1 :1. This is wrong, because then router will confuse like which part has 2 0, which part has 3 zeros. So this is the expressions for shorting the router. Now for example, I was writing IPv4 addresses like this. Sorry, IPv4 like 10.0.0.1/8. So 8 part will be the network ID and this part will be the host ID. 172.16.1.1 this part should be the network ID and this part will be the host ID. So in IPv6, for example, you are writing 2001. I'm using 2001 because it belongs to private IP address. 10, I'm just writing like this, 0. For example, I'm writing here 16. So it means 16-bit is network, rest all part will be used as a host IP address. So that's why that's why I just want to let you know that /64 up to /64 we are not able to use because this is global prefix that I will explain you in another next videos about it. Okay, so in IPv4 we were using like 8, 16, 24 and 32, but in IPv6 we have to use 16, 32 like this and 128. 16, 32, 48, 64, 80, 96, 112 and 128. So this is the basic description. When you are going to work on practical, then you will easily understand. For example, instead of 16, I am using here 96. So means 16, 32, 48, 64, 80, 96. So this part is your network part and this part will be your host part. So when you will configure this IPv6 address, then you will easily understand about the concept of IPv6. Thank you so much. Hello guys. Today we are going to configure IPv6 addressing on Cisco Packet Tracer. So in our last video we have configured IPv4 address and we have taken 5 to 6 network and we have configured PCs, after that routers. So same as IPv4 we have to work on IPv6. In our theory part we have discussed about IPv6 address is 128-bit and it is represented by column. Okay, so here we have 5 networks. First network, second network, third network, fourth and fifth network. Okay, so I need to take IPv6 address. So here I can choose 2001 colon 10:/96. I'm just taking an example. So I'm taking 2001. So 96 represents networks and 32 bits are the host. So here our second network is 20:96. 2001 30:96. 2001 40:96 and at last this one. So I have 5 networks. So how I will configure it? I will provide it 10:1 IP, 10:2 IP, 20:1 2, 30:1 2, and the gateway should be any F0/0 should be configured with 2001 10:3, 20:3 and 30:3. And after that the upper network WAN links 40:1, 40:2, 50:1 and 50:2. So I will configure it like this. Okay, so I will move to my PC configuration part. Okay, so on the PC first I will erase this. On PC in IPv6 configuration I can give IP address 2001:10:1 and /96. This is known as link local address. So gateway should be 10.0.0.3. So double colon represents all zeros, group of zeros. So here I am going to represent 10:2/96 and 10:3. The second network same as 10, but here I will choose network 20:1 96 3. 20:2, So 2001 I have taken just for private IP address. 296.3, and in last 30:1/96 and 2001 30:3. Okay, so now it's time to configure router. So if you want to write, then you can use sticky notes here like these. This is your 10:3. Okay, I will put my keyboard here, that's why it is easy for me. And after that, this is 20:3. This is 30:3. So upper network 2001 40:1 I have to configure. First I will write it that you will easily understand in my video. 50:1 50:2. So I'm click on this router CLI. Okay, in real router you have to use console cable and PC, but on Cisco packet tracer you can directly click in CLI. Okay, so when you are going to configure IPv6 addressing, okay, so one thing you have to be clear in your mind that IPv6 unicast routing should be there. The command IPv6 unicast routing, you have to put this command, because if you don't use this command, then you are able to give IP address to router, but you are not able to give for routing. So interface FA0/0 IPv6 address 2001 10:3/96. No shutdown. Exit. Interface serial 0/0. It is same as we have configured IPv4 address, but the address is changed. 40:1/96. No shutdown. So if you want to save all the configuration, just put do right here, and do show history you can use to see the command that you have used on this. Okay, so next on route 2, here no, enable config, same as IPv6 unicast routing, FA0/0 IPv6 address 2001 20:3/96, which is the gateway for your LAN, and serial 00 IPv6 address 40:2. This link is connected to router 1, the first one. Okay, and serial 001 is for 50, where it is, sorry, 50:001, and no shut, do right. So our second router is also configured. Now move on to third router. No enable config, like these basic commands, enable configuration you have to use every time. IPv6 unicast routing, interface fast Ethernet 0/0. The gateway of this network is 30:3/96. No shutdown. And exit interface serial 0/0/0 IPv6 address, and 2001 50:2/96. No shutdown, and do right. Okay, so every router is configured, and after that you can check the basic commands. Show IPv6 interface brief, show IPv6 interface brief, and in that you can see fast Ethernet is up and IP address is 2001.10:3 and serial interface IP is 2001.40:1. Okay, same as show IPv6 route. In show IPv6 route, C stands for direct network. So 10 and 40 are your direct network and L stands for local. Like it will represent your own IP address but with /128. Okay, so this was the configuration of IPv6 addressing. Thank you.